And as a review, we're going to take a look at the long division with regular numbers first, and then make some analogies on how this works with dividing polynomials. So we put the first number inside the box, and the number we're dividing by goes outside the box. 7 goes into 43 6 times. 7 times 6 is 42, and then we subtract. Bring down the 2. 7 goes into 12 once, multiply, subtract, bring down the 5, and 7 goes into 55 7 times. 7 times 7 is 49. When we subtract, we get 6. Back in elementary school, we would say remainder 6. But after we learned how to work with fractions, we would say the answer is 617 and 6/7. With our second example, we've got a 2-digit number that we're dividing by. So sometimes it's helpful to just look at that first digit and think about it as a 5 versus thinking about it as 53. So 53 goes into 67 once. When we subtract, bring down the 3. I'm going to look at 5 going into 14 instead of 53 going into 143. 5 goes into 14 twice. 2 times 3 is 6. 2 times 5 is 10. When I subtract, I get 37, bring down the 1. Again, I'm going to look at 5 into 37. 5 goes into 37 7 times. 7 times 3 is 21, carry the 2. 7 times 5 is 35, plus 2 is 371. And this time we don't have a remainder. So when we're dividing polynomials, we set it up the same way. The x minus 3 goes on the outside. X squared minus x minus 6 goes inside. And we just look at the first term, we look at the x. So x goes into x squared x times. Or think about it as x times what multiplies to x squared. So x times x gives us x squared. X times negative 3 gives us negative 3x. Now with polynomials, what I think about for the subtraction is adding the opposite. So I add instead of subtracting. Negative x plus 3x is 2x. And the x squared minus the x squared cancels. Bring down the minus 6. X goes into 2x 2 times. 2 times x is 2x. 2 times negative 3 is negative 6. So when I change the signs and add, I have 0 remainder. So thinking about what this means when we divide is that x minus 3 times that answer we got, x plus 2, equals our original question, x squared minus x minus 6. So that's what we're doing when we're dividing polynomials, is we're really factoring. All right, looking at the next example. There we go. All right, so we've got 3x minus 9 on the outside and 3x cubed plus 12x squared minus 15x plus 15 on the inside. Okay, so 3x goes into 3x cubed x squared times, because 3x times x squared is 3x cubed. X squared times negative 9 is negative 9x squared. Again, change the signs and add. So 12x squared plus 9x squared is 21x squared. Bring down the minus 15x. 3x goes into 21x squared 7x times, because 7x times 3x is 21x squared. And 7x times negative 9 is negative 63x. Change the signs. And when we add, we get 48x. Bring down your plus 15. And then looking at 3x goes into 48 16 times. 16 times 3x is 48x. 16 times negative 9 is negative 144. So when I change the signs and add, I get 159. So that's my remainder. So my answer is x squared plus 7x plus 16 plus 159 over 3x minus 9. What I notice is 3x minus 9, they both have a factor of 3, and 159 is divisible by 3. So I can simplify my remainder by dividing everything by 3. So in the denominator, I get x minus 3, 15 divided by 3 is 5, and 9 divided by 3 is 3. So there's my final answer. One more example if you want to take a look at it. This is the last example, so if you feel comfortable with what we're doing, you can stop the recording. So we've got 4x minus 1 dividing into 20x squared minus 13x plus 2. 4x goes into 20x squared 5x times. 5x times negative 1 is negative 5x. Change the signs and add. We get negative 8x. Bring down the plus 2. 4x goes into negative 8x negative 2 times. So when we multiply, and then when we change the signs and add, we get a remainder of 0. So again, this one factors perfectly. So 4x minus 1 times 5x minus 2 equals 20x squared minus 13x plus 2.